Okay, in this video we're going to be talking about real and complex roots and finding different types of solutions. Okay, so first we are finding the roots of each of the following of the quadratic functions. So you're solving for x. So first you got to take this y and replace it with 0 so that we can solve it. So now we're just solving, so I'm going to subtract 9. Opposite of squaring is square rooting. Okay, remember, we have the plus or minus, and to get rid of that negative, we're going to make it an I. Oops, that is not a 3. That is a 9. And the square root of 9 is 3. So I've got x plus 5 equals plus or minus 3i. And then we can just subtract our 5, so x equals negative 5 plus or minus 3i. So I got two imaginary answers in that one. Okay, my next one, because I can't just solve it, I'm actually going to use quadratic formula. So the reason I'm using quadratic formula is because it's not going to be able to be factored. There's nothing that multiplies to 9 and adds to negative 4. So when I use the quadratic formula, I have my a is 1, my b is negative 4, my c is 9. So x equals negative b gets it a positive 4 plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay, so I got x equals 4 plus or minus the square root of 16 minus 36 over 2. X equals 4 plus or minus square root of negative 20 over 2. Get rid of that negative, we pull out an I, so 4 plus or minus I, square root of 20. And if you type that in your yellow calculator, it actually breaks down. So if I break down 20 to 5 and 4, 2 and 2, I would pair them up. One would escape, one would die. So x equals 4 plus or minus 2 square root I. We still got the 5 left under there as 2, and then all of my numbers on the outside are divisible by 2. So 2 plus or minus I square root 5 would be my final simplified answer. Okay, so it says, do either of these functions intersect the x-axis? No, because both of them are complex roots. So no complex roots. What do you notice about the complex solutions for problem 1? Describe the patterns you see, write all observations. So you're kind of looking at the square root of 9 getting you 3, that 5 flipping it and becoming a negative 5 type of thing. But that's not going to mean a whole lot, just kind of the patterns that you see. Okay, so find the sum and the product of each pair. Look for patterns as you calculate. We can create a shortcut if we have complex roots, because anytime I have my imaginaries and the conjugates of them, so one positive, one negative, we can actually make a shortcut to solve them. So first off, the sum. So if I add both of these together, I get 2 plus 2 is 4, and then my i's cancel. Okay, my sum for my next one, 3 plus 3 is going to get me 6. My i's will cancel. Negative 4 plus negative 4 will get me negative 8. My i's will cancel. 1 plus 1 will get me 1. My square roots will cancel, and then you can have the work in there. Product means if we're multiplying, so 2 plus I, 2 minus I. I'm going to show you this first one, and then you guys can go ahead and do the rest of them. 2 times 2 is 4. My outside gets me negative 2i. My inside gets me 2i. And my last gets me negative I squared. So my center will cancel. That negative I will become a positive 1. So I will get 5. Okay, so if I FOILed the next one, I would get 34. If I FOILed the next one, 17. And then 4. Oops, 1 plus 1 should have gotten me 2 there. And there we go. Okay, so we're going to use that in a second. So what complex numbers can you multiply 3 plus 2i by to get it to be a real number? It's conjugate 3 minus 2i, so that my center i's will cancel. Okay, so anytime the next question, 6, it says what complex number can you multiply a plus bi? You would have to multiply by a minus bi to get my imaginaries to cancel and become a complex number. Okay, so create a quadratic equation, so a y equals x squared equation for each pair of complex numbers in the table from number 4, so that here we go. Okay, so the long way of doing this would be to make these my x-intercept. So x minus, I've got my 2 plus I, and I've got my x minus my 2 minus I, because you always flip it when you put it in. Okay, so then we could distribute this negative, and then we would have to FOIL 2 trinomials, which is really ugly. Okay, if we did that, we'd have to distribute this x, then we distribute the negative 2, distribute the negative I, but instead we have a shortcut. So my shortcut is, first we're adding what we get when we add them. So if I add these, I will get 4. And then my next one is what we get when we multiply them. So if we multiply them together, I would get 34. Nope, not 34. I would get 5. Okay, so that was from my table. Added 4, multiplied, got 5. And then my shortcut to making these, I got y equals x squared. We flip this one when we put it in, and we keep my 5 normal. Okay, so if I would have distributed this ugly mess out, my end game answer would look like this, but those would be my roots if I tried to graph them, that they'd be imaginary roots. Okay, but this only works if they're conjugates of each other. So my next one, add, multiply. So if I go back to my table here, if I add, I get 6. If I multiply, I get 34. So I got y equals x squared. We flip the first one, and then we keep the second one normal. Okay, so I go back to my table, my add and my multiply. So my add, I get negative 8. My multiply, I got 17. So y equals x squared plus 8x, because we flip it, plus 17. My next one here, my add, my multiply. So I added, I get 2. Multiplied, I get 4. So y equals x squared minus 2x plus 4. You got to make sure you flip that center one. So if you use quadratic formula, you would get those imaginary roots. Okay, so it says for each pair of numbers below, find a possible quadratic equation that has the numbers as solutions. Okay, so it's kind of the same thing. You can figure out what it, I'm going to start with these ones here first, what adds and multiplies. So if I add them, I get 0. If I multiply them, I get negative 9i squared, so I get 9. So I got y equals x squared plus 0x plus 9, or y equals x squared plus 9. Okay, remember it only works if you have conjugates of it. So my add, my multiply, if I add these, I get 10. If I multiply them, I get 29. So I got y equals x squared minus 10x plus 29. Okay, these are different because they're not conjugates of each other. So what I need to do is I need to kind of work backwards. Okay, so I know it's a minus, so it has to be x minus 3/4, because it's always the opposite of what you think. And then x plus 5. And then I can't have fractions, so I need to bring that bottom forward, kind of like how we do when we factor. And then I need it to be FOILed out, because I need my endgame answer to be x squared. So I got 4x squared here. My outside, I got 20x. My inside, I got negative 3x. And my last, I got negative 15. So if I combine those centers, I get 17x minus 15. So there's my answer for that. Okay, my next one here, we got add, multiply. So I add, I get negative 6. I multiply, I get 7. So y equals x squared plus 6x plus 7. The next one, add, multiply. So I add, I get negative 4. I multiply them, I'm going to get 1. Okay, this one's a little trickier. So if I multiply these here, I've got 4. My outside is a positive 2 square root 3. Inside is a negative 2 square root 3. And then my last is a negative square root of 9, which is actually 3. So minus 3. That's how we get the 1 in there. Okay. My next one, oh, I didn't finish writing it. So y equals x squared plus 4x plus 1. And my last one, when I add it, I get negative 6. When I multiply it, I get 25. So y equals x squared plus 6x plus 25. The hardest part is just going to be that multiplying. So you know your center is going to cancel, so it's really what you multiply to get your front end and what you multiply to get in your back end. So like this one, negative 3 times negative 3 is 9. My back end, I'd get negative 16i squared, which should change to a 9 plus 16. So that's kind of your shortcut because you know your center will cancel. Okay, so complex conjugates, it just says they have the form of a minus bi and a plus bi. The sum and the product will always be real numbers because they cancel out the imaginaries. So based on the following graphs, how many real roots does each polynomial function have? So this one crosses twice, and it is a parabola, so it's going to have 2 real roots. This one crosses 3 times, so it is a cubic. It has 3 real roots. We got it floating above. Okay, so we're going to have 1 complex. Okay, we don't, at least 1 complex. We shouldn't, actually we're going to have 2 complex because it's a x squared graph. There are no real roots. Okay, my next one, it looks like we got 1 real root in here. So do the polynomials in 10 have fewer roots than 9? No, they don't have fewer roots, but some are complex and some are real. So we have the difference of complex and real. How are the roots in C different from the roots in A? Again, complex and real. We have real ones in A, and then we have complex ones in C, and then it's the same thing for D and B. So B has real ones and D does not. They're going to be complex. So considering the graph, how many real solutions does y equals x cubed minus 3x squared plus 3x minus 2 have? So first off, if I was writing that out, this is what it would be factored, so we're going to double check to make sure I factored it correctly. So if I just distribute, I get x cubed minus x squared plus x minus 2x squared plus 2x minus 2. And if I combine my like terms, that is what the original graph is. Okay, so I want to know how many real and how many complex I have of that. So to do that, I'm going to set everything equal to 0. So this one's pretty easy. I got x minus 2 equals 0. So I add 2. I got 1 real at least. Now I got to do this one. So x squared minus x plus 1 equals 0. Does anything multiply to 1, but when I add it gets me negative 1? I can't think of anything off the top of my head, so I'm going to have to use quadratic formula. So my a is 1, my b is negative 1, and my c is 1. So x equals negative b plus or minus the square root of b squared minus 4 times a times c, and those are all 1s, all over 2 times a. So 1 plus or minus 1 minus 4 gets me negative 3, and then we can pull that out with an I. So 1 plus or minus I square root 3 over 2. So I have 1 real and 2 imaginaries in that one. Okay, so in question D, it says how many roots does it have? Well, it has 3, but it has 2 complex and it has 1 real. Okay, my next one's make a sketch of the graph so that P of x equals 0. You have indicated the number of types of solutions. Okay, so my first one, I find the degree. So my degree in this one is 5. My next step is how many times does it turn? So to do that, we do 5 minus 1, so my graph should turn 4 times. And then how many times it crosses the real axis? Well, this one has 5 real solutions, so it's going to cross 5 times. So I got it 1, 2, 3, 4, 5. So I'm going to start down here, and I know it needs to turn 4 times. So 1, 2, 3, 4. And then we got to keep it going to cross that 5th time. So my 1 turn, 2 turn, 3 turns, 4 turns, and then I got my 5 real solutions. Okay, my next one, it's a degree of 5. We just have 2 complex. My turning points, 5 minus 1 is going to get me 4. And then my crossing my real, it's only going to cross 3 times. So 1, 2, 3. But I need to make sure I get 4 humps in there. So if I start down here, 1 hump, 2 hump, 3 hump, 4 humps. Okay, and then that's where my 2 complex is happening, is right in there to get those extra humps. Oops. Okay, my next one, I have a degree of 4. My turning points is 4 minus 1, so 3, and then crossing my real, They're all imaginary, so we're not crossing the real axis at all, but I know I need to turn 3 times. So I want to start my arrow going away, because if I started going down this way, it's going to eventually cross that. So there's 1 turn, 2 turns, 3 turns, and I want my arrow to keep going away from my x-axis. I don't want it pointing down, because that means it could potentially cross my x. And there's my 1 turn, 2 turns, 3 turns. Okay, so my degree is 6, my turning times is 5, my crossing my reel is 2, so 1, 2. So 1 hump, 2 hump, 3 hump, 4 hump, 5 hump. I need to make sure it keeps going away. 1, 2, 3, 4, 5. It goes away so it doesn't cross my x-axis again.